Okay, problem 56. Predict the bond angles around the indicated atoms in each compound. Don't forget to draw in lone pairs where needed to give octets. So you're given three compounds, and the Lewis structure is for the most part given to you, except for some of the lone pairs that are missing. It looks like chlorine needs some, and nitrogen needs some over here. And then you're asked for the bond angles in a few places. Now, first of all, let's just verify the Lewis structures. You remember, you can figure out how many lone pairs are needed by using the common bonding patterns as a guide. So hydrogen will always look like this. So looking at all the hydrogens, they all have one bond. All of the hydrogens look good. Okay, nothing wrong with the hydrogens. They don't need any lone pairs. What else do we got? We got carbons and all of these. So carbons will look like this. Okay, carbon has four bonds. It could be four singles, two singles and a double, two doubles, or maybe a single and a triple. Let's just verify that each of these carbons has one of those bonding patterns over there. So this one has four singles. That's good. This one has four singles. That's good. This one has a single and a triple. So it looks like that. Single and a triple, that's good. So does this one, a single and a triple. That's also a good carbon. This carbon has four singles. Okay. And then here, this carbon right here has two singles and a double. Okay, that's looks like this. Two singles and a double. The central carbon has two doubles. That's also good. And then two singles and a double. Okay, so that carbon also looks like that. So nothing wrong with the carbons in any of these. The last one is the chlorine and the nitrogen. Well, the chlorine is in group 7A. Okay, it's gonna take on the same common bonding pattern as fluorine. Okay, with just one bond and three lone pairs. Okay, so looking at this chlorine, I see the one bond, but I don't see any of the lone pairs. So this one's missing some lone pairs. And then the nitrogen down here, here are the common bonding patterns for nitrogen. Three bonds, and then one lone pair. It could be three singles in a lone pair, a single and a double in a lone pair, or a triple in a lone pair. But nitrogen also gets a lone pair, and it looks like this one is three singles. So it's missing a lone pair. So we're going to have to add three lone pairs to this chlorine and one lone pair to that nitrogen. Let's go ahead and do that. So I've written down the Lewis structures down here. So the first one, the chlorine gets three lone pairs. 1, 2, 3. And then the nitrogen will get one lone pair. And you remember, everything's good over here. Okay, so we did that part. Don't forget to draw in the lone pairs. We did that. Okay, now let's predict the bond angles around the indicated atoms. So here you got these two bond angles. These are around the carbon. Okay, these are around the carbon. Now, what is the geometry of the carbon? The geometry of the carbon, well, you got here, that's this carbon right here. You got 1, 2, 3, 4 atoms that it's connected to. 4 atoms, and I don't see any lone pairs. 4 atoms, no lone pairs. Let's use table 4.2 again. So here are atoms, and here are lone pairs. We're looking for 4, 0. Okay. 2, 0, 3, 0, 4, 0, 4, 0. This is a tetrahedral structure, and the bond angles are 109.5. So tetrahedral looks kind of like this, where you have the central atom, and then the 4 other atoms that it's connected to are pointing towards the vertices of a tetrahedron, and then the bond angles are these angles. So this going to this going to that angle is 109.5, and they're all 109.5. this to this to this is 1 to 9.5, although you can't see it. It's kind of perspective. It's making it look like it's less than that, but it's because, you know, it's pointing away from you in the paper. This is 1 to 9.5, that one. And then this one, they're all 1 to 9.5. Pick any two atoms, and the central atom, the angle is 1 to 9.5. So here, for this guy, you know, these bond angles are 1 to 9.5, and those are also 1 to 9.5. So I'll just say here is 109.5, and then there as well, 109.5. And then what's the other one? The other one was this one right here. Well, this carbon is also tetrahedral because again, I count 1, 2, 3, 4 atoms and no lone pairs. Okay, 4 atoms, no lone pairs, tetrahedral. The bond angles are 1 to 9.5. So all of them are 1 to 9.5. Now, you weren't asked to do this in the problem, but you could draw the structure three-dimensionally if you want. So it's kind of challenging to do this. I'll do it because I've had some practice, but it looks kind of like this. So you got maybe this right here. Okay. So that would be one way to do it. Oops, that'll be the chlorine. And the hydrogen. Okay, so unnecessary to do this, but you know, I don't know. Maybe you don't like that. Here, I'll cross that out. Okay, but you do see those things sometimes. Okay, let's look at B. So here's B. No lone pairs were required for this one because it's just carbons and hydrogens. And the bond angles here, are you got this one, this one. This is around the carbon, and this is also around the carbon. Okay, and then the other one is around this carbon, so that's a different central atom. I'll do that one in a different color. Okay, so the ones around the same central atom should be the same bond angles. Okay, so this time, what is the geometry of this carbon? Let's count the number of atoms and number of lone pairs. I count 1, 2, 3 atoms that this is connected to, 0 lone pairs. 3 atoms, 0 lone pairs. So looking for 3, 0, 3, 0, trigonal planar. And the bond angles are 120 degrees. So 120 degrees, 120, 120. And then what about this carbon? Okay, I see 2 atoms that it's connected to, 0 lone pairs. 2, 0, that's linear. Okay, so this is 180 degrees. And this one is kind of like that one. You got 3 atoms, 0 lone pairs. So that's another trigonal planar. If you want to draw this molecule, taking into consideration the shape, you could do it like this. Oops. Hydrogen, and then carbon, carbon, carbon. How about that? Okay, got trigonal planar, and then linear. So that's actually the shape of the molecule. We didn't have to use any dashes and wedges for this one, so I like that. Okay, the other one with dashes and wedges, kind of ugly. Okay, so the next one, C, we had to fill in a lone pair here. You're asked for the bond angles right here. Okay. You're asked for that one. You're asked for this one. That's another atom. Let's do another color. So you're asked for that one. And then what else? Around the nitrogen. So these two around the nitrogen. Okay, so let's look at the shape of all of these. Looking at this carbon over here, 2 atoms that it's connected to, 0 lone pairs. 2, 0, that's linear. Its bond angles are 180. Okay, looking at this carbon, because that's the bond angle, so that's the central atom. Okay, this carbon, 1, 2, 3, 4 atoms, 0 lone pairs. 4, 0, that's tetrahedral with bond angles 109.5 degrees. 109.5 degrees. And then finally the nitrogen, 3 atoms, 1 lone pair. 3, 1, that's trigonal pyramidal with approximately 109.5 degrees. So I'll just put approximately 109.5 degrees. It's actually a little bit less than 109.5 degrees. And finally, if you wanted to draw that one 3-dimensionally, you can draw it like this. Okay. And then this carbon kind of is here. Okay, I know you might not like these dashes and wedges. How about that? How about that? This carbon is tetrahedral. This nitrogen's trigonal pyramidal, and that would work. Okay. So kind of ugly when you draw lots of dashes and wedges on a structure, but that's how you do it.